Hello wonderful person, this is Anton, and once again, we're going to be discussing something that James Webb Space Telescope has just discovered that should not exist and does not make a lot of sense. Something that scientists have now compared to finding a fully grown, massive tree in the middle of a field that was only planted a few weeks ago. And that's because here what we're looking at is, once again, a somewhat unexpected galactic discovery that reminds us that our current understanding of galactic evolution seems to be incomplete. And so here we have an enormous dusty red galaxy at a redshift of 11, something that 3 or 4 years ago scientists never predicted we would actually find. And so let's talk about why this is such an important discovery and what this means for cosmology. Although naturally this is not the first time James Webb Space Telescope showed us something that's super bizarre and something that challenges current models. And that's because by design the telescope is really good at seeing the edges of the universe, or basically seeing to the very beginning of the universe, the epoch we refer to as the cosmic dawn. Essentially the epoch right there that follows the Dark Ages. And though previous models suggested that we should only be seeing first stars approximately 400 million years after the Big Bang, in reality researchers have now found fully developed galaxies, and galaxies with a lot of activity that was just unexpected. But previous models predicted that at this stage everything should be super primitive. And specifically it should be very small, very massy, and most importantly, extremely blue. Blue in terms of color because when we see a blue galaxy or when we see a blue star, it essentially suggests extremely vigorous star activity and specifically star formation, with most galaxies at this point assumed to be extremely bright and filled with blue light. But this recent study by Giulia Rodriguero and a team from Europe instead discovered a galaxy full of dust, full of heavy elements, and a galaxy that's going to be teaching us a little bit more about cosmology once we actually understand what's going on here. But the first important question here is, so how exactly was this discovered, and why is this the first time we're hearing about this? Well, once again, this was not planned at all. This was not even a planned observation, and instead the team was scouring the data of the Sears field, or basically Cosmic Evolution Early Release Science Survey, when this object was discovered serendipitously. And so here, by using the near-infrared instrument from JWST, astronomers could then analyze the fingerprint from this galaxy, and specifically analyze its light spectrum, in order to find out how far away it is and what's inside of it. And almost right away this was confirmed to be at a redshift of 11.5. This is when the universe was only about 390 million years old. Now this is obviously not the farthest galaxy confirmed, you can learn about that in one of the videos in the description, but this is definitely one of the farthest we've ever seen. And naturally at this point we expect the universe to be extremely primitive and basically only contain extremely powerful blue stars. And so most galaxies that have been seen so far are expected to be blue monsters. Once again blue because they're filled with very young hot stars that did not have much time to build up dust and are mostly producing extremely hot emissions, with many of them have not gone supernova yet. But this galaxy, now referred to as AGS Z11R0, is very different. First of all, it has a very steep UV slope, a measure of how red or blue the light is. And here the slope is -1. For comparison, most other galaxies at this time have a slope of -2.2. Or in other words, they're much bluer in general. Which basically suggests that unlike other blue galaxies, this one seems to be much more red. And it seems to be red because it's dust shrouded. Or essentially the stars in the middle, even though they could be blue, seem to be covered by an enormous amount of relatively thick dust. And though this would not be a problem today, or basically in nearby galaxies, because dust is normally made out of heavy elements like carbon and oxygen, those elements only come from stars that have already lived, died, exploded, and recycled material several times. In other words, we don't actually expect dust, and especially so much dust, to exist so early on. And that's not the only thing that makes this galaxy weird. Here, let's look at some numbers. And so, for example, when it comes to the stellar mass of this galaxy, it's right now estimated to be anywhere between 1.6 to 4 billion solar masses. And while compared to the Milky Way galaxy, it's naturally not very large. It's about 10 to maybe 15 times less massive. But for a galaxy that's only 400 million years old, this is massive. It's essentially 1/10 of the size, existing mere moments following the Big Bang. In fact, this is currently one of the most massive galaxies ever confirmed at such incredible distances. Pretty much most other galaxies are at least 10 to 20 times less massive. But in terms of a lot of other statistics and properties, this seems to be pretty normal. For example, it's currently producing approximately 10 to maybe 40 solar masses every single year, implying that this is an active galaxy. It's also extremely compact, with a physical size of possibly just 180 to 280 parsecs, or approximately 1% of the size of the Milky Way. But in this case, packing billions of stars in just 1% of the volume, with the additional observations of the spectrum clearly showing the evidence of both carbon and oxygen, essentially confirming that there is definitely a lot of dust resulting from previous supernova that happened generations prior, which tells us that even by 390 million years following the Big Bang, this galaxy has already had several cycles involving stellar explosions and continuous recycling of material, implying that these processes very likely started much earlier and seem to have been extremely effective compared to previous predictions from previous models. But more importantly, instead of causing additional issues for cosmology, this potentially solves one really important mystery. The mystery of galaxies like this. This is the giant galaxy known as IC 1101, that's essentially the largest and the most massive galaxy known to us in the entire universe, with the more famous member of these galaxies being M87, the galaxy that became famous when astronomers captured the first ever picture of a black hole from its center, something that was achieved by the Event Horizon Telescope team. And so here the mystery was actually in trying to figure out how these massive monsters formed and how they were able to grow to such sizes in just billions of years. For example, IC 1101, that's several times larger than the Milky Way, seems to be located in a region that does not contain a lot of massive members, almost as if it just appeared out of nowhere and was already large and massive billions of years ago. And though it's quite possible it also absorbed a lot of partners, based on this discovery we can now actually see how these galaxies potentially start and how they eventually evolve into these really massive giants filled with a lot of ancient gas and enormous elliptical structures. So basically this is a kind of a protonucleus of what will eventually become a massive elliptical galaxy. So definitely quite an exciting discovery. Although here I do need to clarify something. Not so long ago we've also discussed the mystery of little red dots, which to some extent also look very similar. They are also compact, they're also red, and they're also mysterious. But based on these spectroscopic observations, this is an entirely different class of an object, because it does produce a lot of different types of emissions we expect from a typical galaxy, unlike those little red dots. In contrast, these objects seem to be dominated by galactic black holes and seem to only produce red light. Once again, you can learn more about this in one of the videos in the description. And so this galaxy seems to be a massive starburst galaxy and only resembles these little red dots because it also contains a lot of dust around itself that changes its color spectrum, just making it appear different. And in this case, compared to those little red dots, even the black hole seems to be much smaller. And so based on the preliminary observations, here the central black hole mass seems to be about 100,000 solar masses. So anywhere from 100 to 1,000 times smaller than inside a typical little red dot. So once again, the main story in this case is really the star formation and the dust. And for astronomy and cosmology, this discovery is important because it challenges the so-called blue dawn theory. Something once again that you can kind of see visualized here. Previously, astronomers believed that pretty much most of the galaxies here will basically be entirely blue, and there's not going to be a lot of dust and a lot of chemical enrichment involving carbon or oxygen. But this galaxy definitively proves that it is chemically evolved, it is dust enriched, and already exists extremely early on compared to what we thought was possible. And because of these unusual discoveries, the scientists behind the study do propose an interesting hypothesis. They actually think that red monsters and blue monsters are possibly the same thing, but just at different ages. And in this model, a galaxy essentially starts as a red monster, but grows very quickly while shrouded in dust, forming approximately 70% of all of its stars during this hidden period. But eventually the radiation from all of these new stars becomes so intense that it basically creates a radiation-driven outflow and blows all of the dust away from the entire galaxy, essentially acting as this massive fan. And so once all of this dust disappears, that's when the galaxy becomes a blue monster, many of which we've discovered in the last decade. So basically it becomes bright, ultraviolet enriched, producing a lot of ionizing radiation. And so if this is correct, it means that there could be a huge population of these hidden red galaxies that we've actually been missing because they're just too dusty to see in the normal ultraviolet surveys. In other words, they possibly all started as these red monsters, but we're just seeing one of them because it seems to be the most massive one. And it's quite possible that many galaxies started the same way. Either way though, we don't really know if this is correct or not. What we do know is that this particular discovery pushes the timeline of the universe just a little bit further back. And so if a galaxy can be this mature and this dusty by 400 million years following the Big Bang, it means that the first stars must have started forming as early as 200 million years. So this here has to be changed once again. And naturally, because of these discoveries, we're going to have a lot more additional observations coming up really soon, mostly focusing on longer wavelengths in order to confirm exactly how much of that red color comes from dust and how much of it comes from other sources. Which basically means that for astronomy at least, there's definitely a lot of secrets to uncover now and a lot more mysteries to solve. And so once there are some additional discoveries, we'll come back and discuss this more in some of the future videos. Until then, thank you for watching, subscribe, come back tomorrow to learn something else, support this channel Patreon where you can find additional videos without any ads and can name it directly, or by joining the channel membership that grants you early access. You can also support this channel by buying the Wonderful Person t-shirt in the description below. Stay wonderful, I'll see you tomorrow, and as always, bye bye.